Hey guys, it's Bill from Linden, Tennessee. So, in this video I'm going to walk through the little implements that I've made and designed mounts for so that I can use one DC brushed motor, a 5 horse continuous, I think it's 12 horse, or sorry, 5 kilowatts continuous, 12 kilowatts peak brushed DC permanent magnet motor. And I've made a little mounting system that I can swap the motor out for all of these different implements, and I'll just kind of walk through. First of all, let's do another rundown of the tractor. I've done this a couple times before, but just in case anybody needs catching up and didn't want to find the other video. So this is just an old Murray riding lawnmower. It used to be 15.5 horse. It was a 42-inch deck. Somebody just gave it to me because the engine was locked up. Turns out it wasn't locked up. It was just the magneto was over tight on the flywheel. Anyway, doesn't matter. Took it out. Version 1 had the motor just sitting directly where the engine was, going into a double pulley. One of the pulleys powered the transmission, and the other one was for the mower deck. And the little lever right there, that was for the to engage the mower deck like normal. And then use the gears on the transmission just like normal. This lawnmower was pretty awful, so I ended up getting rid of the mower deck and moving the motor to back here. So now it's just direct driving the transmission, just with a coupler straight into the transmission. I usually keep it in 5th or 6th gear, and that'll give me a top speed of about 15 or so miles an hour. A little bit more when it's fully charged, but about 15 miles an hour, just plenty fast. And yeah, so, and then I had a little 3-point hitch laying around and decided to just mount it there. And also had a 2-inch receiver hitch laying around and put it on also, because you never know. And this little dude has turned out to be a little workhorse around my 7-acre, I won't call it a homestead because I'm not really a very good homesteader or gardener or anything like that, but property. I use it to pull trailers and just do all kinds of stuff, drag bushes and drag limbs and stuff. And anyway, it's a really, really handy little tool. And I always recommend to anyone wanting to do an electric conversion to do a little riding lawnmower like this first. Because fundamentally, it's exactly the same as a full-size car or truck or Jeep or whatever. But it's just obviously on a much smaller scale. So everything is smaller. The batteries are smaller. The cables are smaller. The motor, everything is smaller and cheaper. And once you've done it, you have learned a lot. You learned a lot to fabrication. You learned a lot about reading wiring schematics and how a DC-DC converter connects into a system, how a controller connects to the throttle, and you got to have a key switch on inputs, and you got to have 12 volts at all time inputs, and just all kinds of stuff. So it's really, really good way to be introduced into the world of electric vehicles. And once you're done, like I say, you end up with something that's very, very useful. These are 2 little 48-volt modules out of a Chevy Volt. And they give me about 2.5 kilowatt hours worth of energy. That's good enough for an hour's worth of mowing, or a full day of just dragging trailers and skidding bushes around. It lasts a really long time if you're not mowing. But so the mower it's a 48-inch mowing deck off of an old Cub Cadet riding lawnmower from like the 70s, and I put a motor on there. Originally the motor was mounted up here in front, and I had like a tensioner, and then once I started the motor, I would have the belt tension sort of off, and then I'd start the motor so that the current draw is lower, and then I'd tension that belt, and then it would fire right up, or the blade would start going. And then I wanted to convert this. So this is a little tiller, had a 5-horse Briggs & Stratton engine on it. This is old. I don't know how old this thing is, but it's real old. And I have it connected to a 3-point hitch, so that I can, just pull it behind me in the garden, and won't wander around. But the problem with that was, to use that motor on this tiller, I had to undo the mounting bolts. So there's 4 mounting bolts that go into the motor. Not only was that a pain in the butt, but it's wear and tear on the threads of the motor. The case of the motor is aluminum, and you don't want to be running bolts in and out of that a lot. Now, I don't really use a tiller very often, once or twice a year, but it was still a pain in the butt. So it occurred to me that back when I built this thing, I had another receiver hitch laying around, and I welded it to the back of the mowing deck just because I had it, and thought maybe I could use mowing deck to pull a trailer, but that never actually happened. So about midnight one night, I thought, hey, let's mount this motor to the male part of the receiver hitch, and then I can put a little bolt on the bottom of that mounting fixture, use that bolt to tighten the tension of the belt, and then do these 2 bolts right there to secure it so it doesn't go anywhere. And so that's what I did, Katie. And then so then I came over to my tiller, which was sort of the first one that I did, and repeated that same process. Put a receiver hitch there, 2 bolts to secure it down, and this little tab here, that's where the bolt on the back of the motor tightens against to tension my belt. Now I have to change the pulley on the motor to run this tiller. I kind of have to do that because I didn't have enough. Well, my belt was big enough. I guess I could have got a bigger belt. I guess I could still get a bigger belt, longer belt, put a bigger pulley on it. Anyway, but it's fine. It works really, really good, so no complaints there. And then I thought to myself, well, I got this chipper shredder. It had a 15 horse, I think it was a Briggs & Stratton also, was it? Whatever it was. It had a 15 horse engine on it, but that engine was really, really loud, like obnoxiously loud. So we took the engine off, made a little mounting system for the motor, and there you go. I can keep the same pulley on it that I use for the mower. Now I use this chipper a whole lot more than I'll use the tiller. I use this quite a lot. So that's that, and that's pretty cool. And then most recently is my pressure washer. This had it wasn't a horsepower rating on it, but I'm guessing it was probably about 5 horse, a 5 horse vertical shaft engine. And yeah, so I made a little mounting device on there. So in this one, I didn't want to put a pulley on there because I wasn't sure if the bearings on this pump were up to the task of side loads from a pulley, because it's designed just to have the engine straight into it. So I mimicked that with the electric motor. So I got a little shaft there with a key in it, and that goes straight into the motor. And then I have what's kind of referred to as a Lovejoy connection. That's a trade, like a manufacturer's name, but you know, whatever. And it's got like a little rubber bushing in the middle, and this is just kind of handy. It absorbs some shock into the pump, and but more importantly, it compensates for misalignment of the motor to the pump. So you know, it saves the bearings in both devices. So in this case, all I do is I take the motor, set it down on here, rotate it 90 degrees, and it sits in right here. There's a bolt that goes through this way that bolts the receiver hitch into this device, and then these 2 just clamp it down so that it stays level. And then I got a little support bracket back there because my tow bar is just lifting straight up on this 1/8 inch piece of steel, and it causes some flex. So that's it. That's all. That's my devices. And the way this works is I got the power on for the thing, and remember I was telling you about how I had that tensioner because I didn't want to have full power going to the motor because it causes a lot of amperage draw, and it can weld contactors together. So I got a little 48 volt speed control off of Amazon. I got a little switch there and a little push to start button here. So what you do is you turn this thing to on. It spins up, get it up to about 70% on the speed controller. Flip the switch, push the button. Now it's running full speed. And if I need to stop it, I'll just come over here, flip the switch, and then turn this back down to low. And all this is doing is this momentary switch is just is a latching circuit, and it's just closing the contactor and bypassing this controller altogether. This controller is only controlling the negative side of the motor, and then the contactor is also controlling the negative side. So at the moment it's coming from the battery up to the controller, from the battery to the contactor up to the controller, from the controller back to the other side of the contactor to the motor, and then when I flip this switch and push the button, that puts that contactor in line, and it completes that circuit, and it powers the whole machine. So that's how that works, and that's how that works with all these devices. The tiller doesn't have a high amp, doesn't have a lot of load, so I can just start it the normal way. But now I went through about 5 of these things, figuring out how they work. Now this is a forward and reverse switch, if I were to put this into reverse, it would short the thing. When it's running, this is actually has like a it shunts the motor when it goes off. See the light comes on. When it goes off, it actually shunts the motor, shorts the motor. And if the motor's spinning too fast, it'll blow this thing out. If I were to turn this switch on now and hit the button with it off, it'll short this thing out. So if you do the math, that's about 5. So I learned all those the hard way. And I put a little 25 amp circuit breaker down here. So this is rated for 50 amps, I think. And then that just pops at 25 so that I don't overload the speed controller. Yeah, so that's all my stuff. It's getting dark, but I wanted to get this video made and put out. And that's my stuff. Thanks for watching. Talk to you later.